Hello! In this video, we will be tackling problem number 2 of problem set topic 17. Problem 2 asks, what are the advantages of working with normalized wave functions? For this explanation, we will consider an electron in a carbon nanotube of length 4. The wave function of the electron is given by psi, which is equal to sine pi x over 2. The graph of psi is shown on the screen as the red curve. We can take the square of psi, and its graph is shown in blue on the screen. By looking at the graph, we see that psi satisfies the requirements for a wave function, namely that it must not be infinite over a non-infinitesimal region, it must be single-valued, it must be continuous, and it must have a continuous slope. Now for this one-dimensional system, the Born interpretation says that if the wave function of a particle has the value psi at some point x, then the probability of finding the particle between x and x plus bx is proportional to the absolute value of psi squared bx. This probability can have a value between 0 and 1. A probability of 1 implies that there is a 100% chance of finding the electron somewhere on the carbon nanotube. Using the Born interpretation, we can evaluate psi squared to find the electron over the length of the tube. Integrating this expression, we then get a value of 2. However, if we normalize the wave function by multiplying a normalization constant n to psi, we can make the probability over all space be equal to unity. Setting n squared equal to 1/2, we find that the probability of finding the electron anywhere along the tube to now become equal 1.